Hello and welcome to the Cisco Enterprise Networking Wireless Black Belt Training Series. We're going to be covering off predictive wireless designs in this instructional video, taking the information that you've learnt about wireless and RF fundamentals, best practice wireless designs, and requirements gathering. We'll be using the Ekahau Site Survey Professional tool to do this predictive design or predictive survey, and taking those requirements that you would have gathered and to formulate a plan on where you're going to be placing your access points and how many access points that you need to meet your coverage and capacity requirements. So this is a quick overview of the user interface. We have the main map area, which is the big white space, which we'll be working with our floor plan, the access points, and where we can see all the visualizations that we'll be using. We have a legend down the bottom right hand side, which correlates with the coverage requirements and capacity requirements that we set in the visualizations menu. We have some shortcuts and toggles along the middle top section here, which I'll go through as we use them. This is the drop down for all of the different visualizations that we can use. So we don't necessarily use all of them for a predictive design, but we can use most of them. We have a toggle here to see whether we want to view 2.4 or 5 gigahertz bands. And we also have some quick views at the top here to see, pass or fail, green or red, whether we're meeting our coverage requirements as we go through and do our design. So you can see there's a planning and survey tab here. So we would use the survey tab if we were doing a validation survey, an AP on a stick survey, or a troubleshooting and gathering some information about the environment. But for this video, we'll be just covering off the planning phase. So this is the Mac OS version. The Windows version works pretty much exactly the same. First, we need to start with a floor plan. Now, Ekahau Site Survey supports PDFs, JPEGs, PNG, most of your popular image files to import. When you import those, you need to add a scale. That's mandatory. You can't begin without a proper scale. We'll talk about that a bit more. And then once you've got the scale in there, you need to start mapping out the attenuation properties of your site. So the walls, the windows, any doors, any elevators, anything that's going to impact the path of your signal. So the big difference between importing images or PDFs versus importing CAD files, which is another option that we have, is that Ekahau Site Survey automatically pulls out all the layers out of a CAD file, and we can map each of those layers to those attenuation properties. So we'll go ahead and do that for this exercise. So I'm going to open a CAD file there. And we can see that Ekahau has pulled up the drawing on the right hand side. On the left hand side here we have a list of all the layers that have been pulled out, and this one has been set up quite nicely. The layer names make sense. We also have some checkboxes on the right hand side of this table, so we can actually remove a lot of this detail that we don't need to include on the plan. We could take out the border, we could take out the scale, we could take out the paper edge, we could take out the logo, the north arrow, border frame. We don't need all of that information when we import it, so we're just left here with the main floor plan. We can zoom in a little bit there. This is sort of a university accommodation block that we're looking at. So we've got details in there. You can see the doorways, you can see the walls, you can even see the room numbers. We'll leave all of that information in there. Now what we'll start doing is mapping attenuation properties to some of these elements. So doors, for example, you can see how they highlight in blue on the right hand side. And we'll map these to interior office doors. And you can see this had a dB loss value here of 4. So this means 4 decibels per meter is the attenuation properties of this. So your wireless signal, whether it's 2.4 or 5 gigahertz, is going to attenuate and reduce in strength by 4 dB per meter. So obviously we're not going to have 1 meter wide thick interior office doors, but for the thickness of that door, so say 8 centimeters, it's equivalent loss of 4 dBs per meters through that door. So this is extremely important to put all of this information into your design, because the more information that's accurate that you put into your design, the more accurate your results are going to be. So let's map the exterior walls. Let's make those brick with a 10 dB loss. There's an elevator shaft in the middle there, which we can allocate some loss values to. Let's head down to the walls. So this will be the interior walls, and we'll treat those as dry walls. So this is a good time to raise that. It's a best practice to do a pre-design audit of the site. If you're able to get on site and inspect what the walls are made of, there's a lot of times you'll find that dry walls aren't actually dry walls. It's just plasterboard that's been put over brick walls, and that makes a huge impact into your wireless signal propagation. So it's definitely, as part of your requirements gathering exercise, it's definitely recommended to go on site and do a visual inspection. That will also help you identify where you can potentially run cabling and where you can actually install your access points. So let's map some of these windows as well. I think they're exterior windows, so we'll make them thick because they're probably double glazed, and that should be good to go. And we'll go ahead and import that. So this will take a little while depending on how fast your computer is. So there we go, it's imported there, and oh, it looks like it's imported some border elements there that we don't need. So this is a good exercise. So I'm going to delete these border walls that we've got here. So I've selected the top one. You can see that it's highlighted with the white squares on either end. Now to select multiple elements, on Mac you hold down the Command key, on Windows you hold down Control, and you can just click on multiple elements, and I'm going to press delete to get rid of those walls that we don't need. And I can zoom in a bit here, and you can see that Ekahau has imported all of the attenuation properties that we've allocated there. You can see that it's automatically shut all of the doors. We want to consider the worst case scenario that all of the doors are shut, and you can see the different color codes for the different properties that have popped up on this plan. So that's great. We've got the floor plan in there. We've got the walls and the windows and the doors and everything mapped out. The next mandatory thing that we need to do is actually set a scale. So I'm going to pop out this menu on the left-hand side because it will be relevant shortly. So we have an access points list on the left-hand side as well as a building tab. So the building tab is going to be useful when we do multi-story designs. So whether we've done a manual drawing of the walls into this plan or whether we've imported the CAD file, it's a good idea to make sure that we've got the scale set accurately. So it's a really bad practice to base the scale off the width of a small doorway. I know a lot of people try and do this saying that the door is 80 centimeters or 90 centimeters or 1 meter, but that doesn't scale out well for the scale of the pixels for a large plan such as this one. So it's best to take a measurement on site, hence the recommendation to do a pre-design audit on site, and take a measurement of a long distance that you can find, such as a long hallway, even a really large room. The bigger the room or the longer the distance you can measure, the better. So I know that this site is actually 80 meters, or actually 82 meters wide to be precise. So I'm going to click and drag across while I'm holding down. That's left click. You see the CAD import has actually brought it up as 78 meters there. So I'm going to release my left mouse button and actually just type 82 and hit enter to set that scale. So the scale is set for that plan properly now. So each time we use a different element of these tools at the top, to return to the view or the manipulate or edit option, we just click the mouse pointer, and then that's what we can do by selecting different elements. So we've got the scale there, which is great. Now what we need to do is actually start inputting some of our requirements into this plan. I'll come back to the building tab later because we'll make this a multi-floor plan. So if we hop along here, we've actually got a requirements tool, and where we put that in is the area tool. So we have a requirements area. So you see on the pop-up there, it says that it captures both coverage and capacity requirements. So I'm going to draw an outline here. I'm going to left click and trace along this edge, and you can actually use the command or control button and hold that down to get some finer control over where your requirements area is going. So I'm going to do this quite quickly for the purposes of this exercise. But I'm basically tracing the area that we need to provide wireless coverage for. So you might not be providing wireless coverage to all of a site. It might only be part or half of the site. But this is where we're telling the software that we need to meet our requirements and place access points within this area. So I'm just going to finish this off a bit roughly, but you can see that it joins the edges there. I've done my last click there, and I'm going to right click to end drawing that area. And you'll see at the top here we've got area 1, and at the moment we have voice and data requirements, and we have some devices numbers there. So I'm actually going to edit those details here. And Ekahau Site Survey has some built-in profiles here. You can see there's a Cisco Design Guideline 1. I'm just going to pop that up and have a look at the Cisco Design Guideline. And you can see that we have some requirements here built in for signal strength at -65 dBm, signal to noise ratio of 25 dB, minimum data rate of 12 megabits per second. Make sure that we have visibility of at least 2 access points at -75 dBm. So that's good for when you're trying to design redundancy into your wireless network, so that if a radio goes offline or changes channel or the access point dies, will your wireless devices see another access point nearby close enough that it can roam to? On the topic of roaming, this is also a metric that can be used to design or help to design for voice over wireless, and make sure that you have sufficient overlap or sufficient visibility of at least 2 access points from your wireless client's point of view, so it can start to make some roaming decisions as you're walking throughout your site. We also have channel overlap. This is where you have overlapping channels. So in 2.4 gigahertz, depending on your regulatory domain, for example, in Australia, we can use channels 1 through to 11 in 2.4 gigahertz, and only channels 1, 6, and 11 are non-overlapping. So we really don't want to have access points overlapping those channels too much, but it's sort of inevitable in 2.4 gigahertz. Whereas 5 gigahertz in Australia, we have about 20 to 23 channels that we can use in the 5 gigahertz band. So it's a lot easier to avoid channel overlap in 5 gigahertz. So I'm going to set the Cisco Design Guideline as our requirements, and you can see here that's for our coverage requirements. This is where we start to go into capacity requirements. This is where your requirements gathering comes into play. So for this exercise, I'm going to keep it relatively simple. So you can see that we've got the option to add some devices. I'm just going to add a couple of different devices here. Each time I click Add Devices, it pops up with another row of devices here. So I'm going to specify 100 generic laptops, and you can see there's some built-in profiles here for different devices and different capabilities. I'm going to specify 150 smartphones, and I'm going to put 50 generic tablets. So you can customize those details if you need to. You can customize your device profiles. We also have application profiles that are built in to Ekahau Site Survey. So perhaps all of these laptops are just sort of doing web and email traffic. The smartphones, they could be doing, streaming music, for example, and the tablets could be doing streaming video. Now, you wouldn't necessarily put the total number of devices in here. You've got to consider sort of what the average load is expected to be, or the average use case. So you might have 200 laptops, but maybe only expecting 100 of them to be associated and using and actively passing traffic on your wireless at one time. Same with these traffic profiles, is you're not necessarily expecting every device to be using 10 megabits per second all the time, for example. So you've got to use some good judgment around what your likely traffic load is going to be. So let's maybe just put one of these at a bit higher. Let's just say high SLA 4 megabits per second. So you can see at the top here of a summary, 300 devices, total bitrate 424 megabits per second. So that sets some coverage and capacity requirements. So now we need to start doing some planning. So what we can do is we can use the auto planner that's built into Ekahau Site Survey, which takes those requirements and starts to place some access points for us. So you can see up here we've got our requirements, coverage and capacity is being considered in the plan. Now we need to select the access point model that we want to start to work with. So there's hundreds of different access points in here. There's all sorts of different vendors. All of the Cisco access points are in here, both indoor and outdoor access points with internal and external antennas, omnidirectional, directional. So we have a lot to choose from. What we're going to use for this exercise is the Cisco 3802i. And we have some options here to set the transmit power levels. I'm going to leave those as default by now. Those are sort of typical values that most wireless networks get deployed at. Obviously, you can adjust your transmit power control levels to be certain minimums and maximums, but this is sort of a good middle of the range to go for 2.4 and 5 gigahertz to start with. So we can actually do some advanced settings here. We can actually specify antenna heights. So if we're working with a higher ceiling in the site, we could actually specify all access points to be at a different height. We can specify the channels that can be used. So for example, I can expand here what 5 gigahertz channels we're allowed to use here in Australia. So this will be different depending on what regulatory domain you set the software to. And you can actually change the channel bandwidth in here. So you actually have an option, I'll show you after this, where you can actually alter the channel planning as well separately. From a capacity point of view, we can actually allow dual 5 gigahertz operation on applicable access points, which is pretty cool. Minimum data rates, band steering, so we can actually specify whether we're expecting, more 5 gigahertz capable devices to connect or 2.4 gigahertz. So again, that's going to be dependent on your requirements gathering, what devices are going to be in use, whether, for example, all corporate traffic is going to be pushed to 5 gigahertz. There's going to be a lot of factors that can influence whether you want to use this feature or not. Same with the number of SSIDs per radio. It's best practice not to go too overboard with the number of SSIDs, because the more SSIDs that your access points are advertising, the more overhead there is in beacon management frames. So let's just use that information to go ahead and create a plan. So Ekahau Site Survey will do some number crunching and then place some access points for us to try and meet those requirements. So here we go. So this is what Ekahau has come up with. And we can see on the left here a list of the access points it's placed. So you can see it's placed 14 access points. And so we basically just reached a quick bill of materials to meet these requirements. You can see that our coverage is meeting the requirements everywhere. We don't have any gray spots. The visualization legend down here on the bottom right has a signal cutoff of -65 dBm. Anything below that should be showing as gray. And we've got everything covered here to start with, which is pretty cool. So we're viewing signal strength at the moment. Let's just check if we're meeting our signal to noise ratio requirements, and yes we are. No gray in that area, which is pretty cool. If we also want to do a further analysis of whether we're meeting our requirements, we can actually click on the visualization statistics option up here on the top right, and that gives us a breakdown in different scales of how well we are or aren't meeting our requirements. So there's a few minimal pixels on the screen there which have got some gray areas, but they're nothing to worry about. What else can we have a look? We want to have a look at channel overlap to make sure that we're not going to have overlapping channels in 5 gigahertz, which is pretty good there. Let's swap over to view 2.4 gigahertz. Now, as I mentioned before, it's kind of hard to avoid 2.4 gigahertz channel overlap. The great things with the Cisco Wave 2 access points like the 2800, 3800s, and 4800s using flexible radio assignment, meaning it can dynamically change those radios from 2.4 gigahertz into 5 gigahertz client serving radios or monitor mode. So, Cisco's got the smarts there to be able to actually adjust those radio modes and optimize the network automatically for you. So we don't need to worry about this at this stage too much. We can look at a high-level overview of whether we're meeting the requirements on a network issues view. So this gives a color code as per each of those coverage requirements as to whether we're meeting them or failing them. So we can see a lot of pink there for channel overlap. If we go to 5 gigahertz, really the main issue that we have there is number of AP visibility. So let's just zoom in a bit closer on that. We've got this access point here, which is on channel 11 and channel 40. We've got an indication here of the antennas. This is an internal omnidirectional antenna AP, so we don't really need to worry about those antenna symbols. But you can see that, we've got an issue here with meeting the number of APs visibility. So we could choose to place an additional access point in there to rectify that. So let's go ahead and do that. we have the access point icon up the top here. So Ekahau Site Survey can now do planning for Bluetooth as well, which you'll see here. So if you were doing planning with the Cisco 4800 access point, you would actually see the Bluetooth radio show up on the access point and view some Bluetooth coverage. So that's quite cool too. So let's have a look in the list again. So we can type and filter into this list and select, let's select a dual 5 gig Cisco, let's make that the 3800 so it's the same as the others, a dual 5 gig 3800. And we'll place that here in this reception area. And so we've got rid of the number of AP visibility issue, but because we placed this access point and by default it places itself on channel 36 on both radios, we've got excessive channel overlap there, hence the large amount of pink in this area. So what we can do is use a subset of the auto planner called the channel planner and try and rectify that just for our views here. So this is where we could play around with different channel widths. Let's say we wanted to do this plan for 40 megahertz wide channels. You'll see that it's reduced the number of total available non-overlapping channels, but has bonded them together. And we could go ahead and create that plan. So not too bad. We've still got some channel overlap here. We've still got some issues with AP visibility. I'm just going to move this back to 20 megahertz wide to make sure that we get rid of that channel overlap. And if we zoom out, we've done a pretty good job. There's a couple of areas on the edges, on the top right and the bottom left, where we don't have second AP visibility, but for this design, it's quite sufficient. So I'm going to head back to signal strength. And what we're going to do is just showcase doing a multi-floor building. So I'm going to actually add a building in here. I'm just going to leave it called building 1 at the moment, and we can select the map and add that floor to the building. And then we have a building view here on the left hand side. So we can see what the height of the building is. 2.5 meters is the default height, so you can edit that. It might be a 3 meter high floor, or it might be 3.5 meters. And I'm going to actually go ahead and add a floor above that one. But we don't have another map. So typically you'd probably add in a second floor that you'd have the map for. For this example, I'm actually going to duplicate the map from the menu here. We've got the map menu at the top. I can simply go duplicate map, and it pops up with a copy of Walk in the Park there. So you can see what it's done. It's copied the floor plan, it's copied all the walls, it's copied the requirements area, but doesn't copy the access points because your requirements on the other floor might not be quite the same, so you might need to tweak the requirements. So let's go ahead and just add this to the building here. Walk in the Park copy for level 2. And you'll see here there's this 3D status aligned floors and these little red icons here. So Ekahau Site Survey can actually take into consideration the 3D or vertical as well as horizontal signal propagation throughout your plan, which is really fantastic. So it enables you to do multi-floor plans and make sure that you're not stacking access points unnecessarily on top of each other, and it makes sure that you're considering signal bleed above and below floors to make sure that you don't have clients connecting across floors when they shouldn't be. So you have that full visibility there, which is great. So to align the floors, we actually need to make use of another tool here, which is the alignment point tool, which I'll click on here. And we need at least 3 alignment points to actually align these floors. So what I'm going to do, it's usually good to use a common area across both floors. Typically you'd have elevators or fire stairs will be in common areas. And you can actually see in this plan we have a couple of fire stairs on the right hand side, in the middle, and on the left hand side as well. So I'm just going to draw some alignment points, 1 on each of these fire stairs, because we need a minimum of 3 points to have the software draw a virtual plane in the background. So I'm going to do the top left of each of these fire stairs. And what I need to do is then do the same thing on the floor below and put the same number of points in the same location on this plan as well. And you'll see that it'll go alignment point 1, alignment point 2, and we'll go to the right and do alignment point 3 up here. And you'll see on the left-hand side, our 3D status has now become OK, which is fantastic. So now we can see in the software what's happening between both floors. Now, if we swap back to the top floor of the building, we can actually see now that there's some signal bleed up through the ceiling of the ground floor. So this is a signal bleed of the access points back through the floor, which is quite cool to see. So you can make sure that you're not stacking APs directly on top of each other and do another design there. So what we could do is we could go ahead and rerun the auto planner for both the floors now. I'm going to leave everything else the same. Maybe I'll make the number of devices half, for example. So we'll just see if we get some different results coming up on the top floor. Probably going to be very similar. So what this does is it actually overwrites the original access point placements on the first floor, and it starts again from scratch. But we've now got this list here of all the access points. It's done 14 on both floors. We can see which floors the access points are on. If you wanted to go to a next level of detail for your design, you can actually see per access point and per band what the mounting height is for the AP or the antenna. You can see some quick views here of the transmit power. You can actually go in per access point and change the transmit power per AP. If you were working with external directional antennas, you could play around with the down tilt. And if you were playing around with external antennas, you can actually go through the whole library of different external antennas and attach those to your access points too. So there's a lot of flexibility there. So now that we've got this design and we've got a multi-floor design that's working quite nicely for us, I'm going to just show you quickly how you can export this information into a report. So Ekahau has two reporting tools. They have the one-click reporting tool as well as template reporting. So template reporting makes full use of all the capabilities of Ekahau, and using fully customizable template reports, you can take a Word document and have all of these different code tags to represent the visualizations and the heat maps and everything customized the way you want it to be viewed. So different color schemes for the heat maps, different ways to show the access points, different tables of information. So I highly recommend checking out Ekahau's YouTube channel because I have some fantastic webinars on template reporting and how you can make use of that, as well as a link to a Google Drive area which has got some templates in there that you can get started with. So I highly recommend doing that. Ekahau has also some other fantastic webinars on there, lots of instructional and educational webinars, as well as talking with people in the industry about best practices for different deployment scenarios, what's new and what's the latest and what's coming in wireless. So it's a really great resource there. Anyway, what we're going to show you is Ekahau's one-click reporting, which is the nice and easy built-in tool. So this allows us to specify whether we want to show heat maps and information for both 2.4 and 5 gigahertz bands, which floors we want to include in the report, and the format down the bottom can either be Word document or PDF and A4 or A3. So I'm going to leave this as a PDF document. Actually, no, I'll make it a Word document, and I'll show you what you can edit later on. You can actually choose a specific cover image. The default one is this Ekahau logo, so you could put your own logo on there. And now we have all these different sections that we can choose to include. Now, we don't necessarily need to include all of these for predictive design. You can do, but not all of these pieces of information are going to be relevant for predictive design. So keep a note of what ones we enable and disable in here. So what's good to include on a predictive design? Signal strength, yes. Signal to noise ratio, yes. Channel overlap, definitely. Number of APs, definitely. Interference / noise, no, we don't need to include that in a predictive design because this is actually something that is measured doing a validation or troubleshooting survey. Data rate, you can include that for a predictive design. It's just a predicted theoretical maximum data rate that you should get based on the signal to noise ratio. If you'd done a survey, this data rate would be based on the measured data rate that you've actually associated it. Throughput, again, for a predictive design, you don't need to include that because it's just a function of signal to noise ratio in this predictive design. Whereas if you did an actual active survey as a validation survey, this would be a real throughput that's measured using an iPerf throughput survey. So I'm going to exclude this for a predictive design. Now, connectivity, again, focuses on active surveys that you'd actually do on a live environment. So we wouldn't be getting any of this information from a predictive survey, so we can untick all of that. Spectrum, again, is from an active survey. So if you're using the Ekahau Psychic survey tool to do some spectrum analysis and gathering that information, you'd be doing that with a passive and active survey that you're walking around for a validation or a troubleshooting scenario. So we won't have any of that information in a predictive design, so I'll uncheck that. Requirements, we definitely want to include these network health and network issues. Requirements for capacity, we definitely want to include all of those too. Bluetooth coverage, if you're doing anything with Bluetooth planning, so BLE, asset tag tracking, location tracking, that sort of stuff, you can definitely include Bluetooth. Access points, we definitely want to include. Bluetooth devices, we'll exclude those as those are survey related. Any notes. So Ekahau actually has the ability to add in custom notes throughout the plan. You can add notes to each access point, you can add pictures, you can take photos when you're doing your on-site audit. You can even add cable notes if you need to depict on this plan where the cable runs are going to be and how long they'll be. Survey bookmarks are related to passive or active surveys. Same with access points without position. So we're pretty much good to go here for a predictive design report. So I'm going to call this test report, and you can choose where you're going to save this document to. So I'm going to save this to my working folder at the moment, Ekahau, and click on generate report. So now this will take a bit of time, again, depending on how quick your machine is. So you'll see Ekahau go through multiple different stages for generating this report. So the more information or the more detailed your plan is, the more access points you have, the number of floors you have will impact how long this report will take for you. So it might be a good chance to go and get a cup of coffee while you're waiting for these reports to run. Your mileage will vary depending on the specifications of your computer. So Ekahau's finished generating our Word report for us now, and it's popped that up for us on the screen. So we'll just quickly walk through what's in this report. So because this is a Word document, you can edit these and crop the images and resize them if you need to. So it shows an overview of the coverage areas, and it gives you an overview of the coverage requirements and the capacity requirements that it's pulled out of the project file. And it goes through and it gives us a breakdown of the signal strength for each of the views here. So for example, I might want to crop this one and actually make it a bit bigger. So when you actually do template reporting in Ekahau, you have a lot more flexibility over how this is all formatted and how it displays on your screen and what size you want it to be, whether it automatically zooms in, whether it shows you access points and the radios and the channels on your plan. It gives you a lot more flexibility there. So it gives us the primary signal coverage for both 2.4 and 5 gigahertz. It gives us the signal to noise ratio for both bands, and it gives us a view of the channel overlap, which you can see is pretty bad. So we've got the different levels here of grey, indicating how badly we're not meeting the requirements. And 5 gigahertz here, we don't have much channel overlap, which is pretty good. Number of APs, so this is a view of the number of APs. So we have a minimum of 2 at negative 75 dBm, and we're meeting that there. It checks both bands for that one. The data rate, which is the theoretical data rate, so you can see 225 megabits per second on 2.4, 5 gigahertz. We've got 300 megabits per second, so that's based on the signal to noise ratio and having the access points configured with 20 megahertz wide channels. Network health, 2.4 is a fail. That's because of the channel overlap. 5 gigahertz is green in most areas. Network issues, so this is the other view that we went through in the demo of the software. And so 5 gigahertz, we can see we've got a bit of channel overlap in that top left-hand corner, which we could fix. So we didn't have that when we did the single floor plan, but that overlap came in when we did the second floor plan. So that's why it pays to use the 3D features in Ekahau Site Survey to make sure that you don't have too much signal bleed above or below. So we might need to tweak some of the transmit powers of those APs in that area. And that's something you could do after you've done a validation survey of your deployment and tweak your transmit power control levels. So I'll just skip a bit further through the document. It's quite useful having all of this information in there. It gives us a good table here. So this is a fantastic table here, which is what you can use to generate a bill of materials essentially. And it tells you the configuration that each access point was modeled on, gives you the access point make and model, gives you the transmit power and the channels that they've been modeled on. So that's quite fantastic. So if you did the template reporting, you could summarize this even further into a, Cisco access point model number blah and quantity, 28 for example, and summarize it that way. And so it splits out both floors. And right at the end, we have the network capacity configuration in terms of what we put into the auto planner. So it's a good quick output of a lot of the essential information that you'll have from your predictive design. And that's pretty much what we wanted to cover here with doing predictive designs. If you need to learn more about predictive designs with Ekahau, as I mentioned, check out the YouTube video channels. They have lots of great instructional videos on there. They have some great blog posts and online support on their website. And they're also running their own full expert level training programs as well around the world and in the region. So thank you very much for watching this instructional video. I hope it was useful for you.